Have you ever wondered how computers manage data in an organized way? One such data structure is the stack, a simple yet powerful tool that mimics a stack of books. Let's dive into what a stack is, how it works, and how to implement one using dynamic arrays in C. What is a stack? A stack is a linear data structure that follows the last in, first out principle, or LIFO. The last item added to the stack is the first one removed. Think of a stack of plates at a buffet, only the top plate is accessible. Stacks support three main operations: push, add an item to the top of the stack. Pop, remove the top item. Peek, view the top item without removing it. Static versus dynamic arrays for stacks. Static arrays. Stacks can be implemented using static arrays, where the size is fixed during initialization. But what happens if the stack becomes full? You encounter a problem called stack overflow. Dynamic arrays. Dynamic arrays solve this problem by resizing automatically when the stack reaches capacity. This makes dynamic arrays an ideal choice for flexible and efficient stack implementation. Why dynamic arrays for stacks? Fixed-size arrays limit how much data we can store. A dynamic array allows the stack to grow as needed, making it a perfect choice for implementing stacks. With this approach, you'll never face stack overflow. Initialize and resize. Next, we initialize the stack with a fixed capacity and implement a function to resize the stack dynamically when it's full. Step-by-step stack implementation in C. First, we define a structure to hold the stack data, top index, and capacity. Next, we allocate memory for the stack and its dynamic array, setting its initial capacity. Next, the push function checks if the stack is full. If so, it resizes the array to double its capacity before adding the new element. The pop operation removes the top element. If the stack is empty, it throws an underflow error. Peek allows us to view the top element without removing it. Applications of stacks. Applications in programming. Stacks have a variety of applications in programming and computer science: expression evaluation, checking balanced parentheses or postfix evaluation. Undo operations, in text editors and software applications. Function calls, managing recursive function calls in programming. Applications in everyday systems. In everyday systems, stacks are used for web browsers, tracking back and forward navigation. Call logs, managing recent calls and phones. Advantages of stacks. Simple and intuitive structure. Stacks provide a straightforward way to manage data with last in first out, LIFO, behavior, making them ideal for tasks requiring reverse order processing. Efficient operations. Both push and pop operations run in O(1) time complexity, ensuring fast addition and removal of elements. Memory optimization with dynamic arrays. Dynamic arrays expand their size automatically when needed, avoiding the limitations of fixed-size arrays and preventing memory wastage. Advantages of dynamic arrays in stack implementation. Flexibility. No need to predefine the size of the stack, allowing for growth as more elements are pushed. Efficient memory utilization. The stack uses memory only as needed, freeing up unused capacity for other parts of the program. Reusability. Once an element is popped, the memory it occupied can be reused for future pushes. In this video, we covered the fundamentals of stacks. Implementing stacks with dynamic arrays in C. Real-world applications of stacks. Conclusion. Stacks are a foundational data structure with endless applications. By implementing them using dynamic arrays in C, we ensure scalability and efficiency. Start exploring stacks today and unlock their potential in your coding projects.